Okay, I will start this session. Here, uh, we are going to determine the response and solution using differential equation method for RC circuit with AC supply. Okay, so for the RC circuit with AC supply, we are going to determine the response and solution using differential equation method. So, let us consider RC circuit. R and C, they are connected in series and there is a switch. This is our AC supply, that is V of t is equal to Vm sin omega t plus phi is our AC supply. So here initially capacitor is not charged, so voltage across the capacitor immediately after closing the switch will be equal to 0. Okay, so at t is equal to 0 plus immediately after closing the switch, voltage across the capacitor is 0 and the switch is closed at t equal to 0. Okay, if you want you can draw the diagram. Okay, now apply KVL to the given circuit. Okay, write down the KVL equation. R into I plus 1 by C integral of I of dt is nothing but source voltage equal to source voltage Vm sin omega t plus phi. So source voltage is equal to the algebraic sum of the voltage drops in the given circuit. What are all the voltage drops? R into I and 1 by C integral of I dt. So consider it as equation number 1, KVL equation. Now just rearrange the terms. Okay. So what I have done is of course for RL circuit we can simply rearrange, but here it is not possible. Why? Because here integral part is there. So that's why what I have done is um, I have differentiated with respect to time. So what did I get? R into di by dt plus 1 by ci. Integral and differentiation cancel each other. And Vm is constant. Differentiation of differentiating sine omega t plus phi with respect to time. What do you get? Omega cos omega t plus phi you have got. So simply uh, what I have done, I want to convert that into some homogeneous or non-homogeneous, whatever. So that I can find out the solution for the given the expression that I have got by KVL. Okay, so for that simply I have differentiated with respect to time. So if you differentiate with respect to time, okay, so R is constant, you will get R into di by dt plus integral and differentiation will cancel, 1 by ci you will get, and Vm is constant. Differentiation of sine omega t you will get omega cos omega t plus phi. And later on, what you can do is I want di by dt. I don't want any coefficient here. Okay, so I have divided with R on both sides. Okay, I have divided with R on both sides. If you divide with R on both sides of this expression, so you will get this. What do you get? And di by dt plus 1 by R ci is equal to Vm omega by R cos omega t plus phi you will get. Consider it as your equation number 2. Okay, di by dt plus 1 by R ci is equal to Vm omega by R cos omega t plus phi is my equation 2. Now compare it with your non-homogeneous equation. It is similar to your non-homogeneous equation. You see, I is nothing but x. 1 by RC is P. And this whole term is K. Okay. So what is P? 1 by RC. What is K? My cursor won't listen to me. It's very irritating. So Vm by R omega cos omega t plus phi. So now we can write the solution for this expression. It will have, as you might be knowing, the solution is what? It will have two parts. Solution of the current will have two parts. One complementary part and another one is particular part. So let us see the complementary part. So complementary part and the particular part are the solution for the equation 1. So I equal to ICF plus IP. So what is ICF? Complementary part of your solution. ICF is C e to the power of minus PT. What is P? 1 by RC. So ICF is equal to C e to the power of minus 1 by RC t. So consider this first one as 3 and this one as equation number 4. Okay, so particular you have written the complementary part solution equation. ICF is equal to C e to the power of minus 1 by RCT. Okay, so complementary part is over. Next we have to go for particular part. So what is particular part? IP particular part is A cos omega t plus phi plus B sin omega t plus phi. Simple expression. Consider it as equation number 5. So IP is equal to A cos omega t plus phi plus B sin omega t plus phi. Now differentiate this equation number 5 with respect to time. If you differentiate it with respect to time, you will get d by dt of IP is equal to minus A is constant of course. Differentiation of cos omega t will get minus omega cos sin omega t plus phi, and differentiation of sin omega t will get omega cos omega t plus phi. Okay, consider it as your equation number 6. Okay, so I have IP. I wanted d by dt of IP. So I just differentiated equation 5 with respect to time. So I have got equation 6. Okay, now you can substitute this 5 and 6. Okay, 5 and 6 in your first equation, that is equation number 2. So what is equation 2? Let us see. This is our equation 2. In this equation 2, substitute IP and I here. Okay, so I will write P there so that it will be easy for you to understand. Consider this as d by dt of IP and consider this as IP. Substitute d by dt of IP and IP in your equation 2. So if you substitute, you will get this. So minus A omega sin omega t plus phi plus B omega cos omega t plus phi plus 1 by RC into A cos omega t plus phi plus B sin omega t plus phi in I is equal to, I will just string this equation, now it is okay. Okay, so after substituting the d by dt of IP and IP in your equation number 2, you will get minus A omega sin omega t plus phi plus B omega cos omega t plus phi plus 1 by RC into A cos omega t plus phi plus B sin omega t plus phi into I is equal to Vm omega by R cos omega t plus phi. So consider this as equation number 6. Okay, if you remember the, what to say, the response of RL circuit using differential equation method, if you remember, we have followed the same pattern there also. Here also we are following the same pattern. So now compare the sign coefficients in this equation number 6. What are all the sign coefficients? Minus A omega is one sign coefficient. Another sign coefficient is yeah, 1 by RC into B. That is equal to right side no sine term, so equal to 0. So if you compare sine coefficients, minus A omega plus B by RC is equal to 0, you will get from equation 6. So just rearrange the terms and write in terms of A. A is equal to B by omega RC, you will get. Consider it as equation number 7. Okay. Now, let us compare cosine coefficients. So if you compare cosine coefficients, see here, B omega is there. After that, 1 by RCA, that is equal to Vm omega by R you will get. So, B omega plus A by RC equal to Vm omega by R. That's considered as equation 8. Now, substitute 7 in 8. If you substitute 7 in 8, you will get B omega plus B by omega R square C square equal to omega Vm omega by R. That is equal to B. Okay. So here only B terms are there, so you can easily determine B. So B is equal to Vm omega square R square C square by omega square R square C square plus 1. If you simplify further, you will get B is equal to Vm R whole divided by R square plus 1 by omega C square. Considered as equation number 9. So this is B. Now you can substitute B in any equation 7 or 8 and you can get A value. So see here, I have substituted 9 in 7. So I have got A is equal to Vm by omega C into R square plus 1 by omega C square. Consider it as equation 10. Okay. Now substitute this A value and B value in your equation 5. So if you substitute A and B value in equation 5, you will get IP is equal to Vm by omega C into R square plus 1 by omega C square cos omega t plus 5 plus Vm into R divided by R square plus 1 by omega C square sin omega t plus 5. Consider it as equation number 11. Okay. If you are writing it down, write it quickly. Okay, now if you look at this IP particular solution of your current equation, these terms are very big. We can replace them with some notation, some m sine theta. I can't write. Okay, to make the equation simple, we can replace this term with m sine theta. Okay, this whole term can be replaced with some notation m sine theta. This whole term can be replaced with some other term m cos theta. Okay, you can replace with m sine theta, m cos theta. So equation 11 will be modified. Okay, so here I have written. So to equation 12 is what? M sine theta is equal to that first term, that is Vm by omega c into r square plus 1 by omega c square, and m cos theta is Vm into r by r square plus 1 by omega c square. So equation 12 and equation 13, you can replace equation this 12, what to say, this bigger terms with smaller terms, that is m sine theta and m cos theta. So now our particular solution modified equation is what? IP equal to m sine theta cos omega t plus phi plus m cos theta sine omega t plus phi. In this equation, you can take m common. If you take m common, so what is our expression now? IP equal to m into sine omega t plus phi cos theta plus cos omega t plus phi sine theta. So this is looking like a sine A into cos B plus cos A into sine B formula. It is looking like that. So sine A plus B. So IP is equal to what? M into sine A plus B. Sine A is omega t plus phi, B is theta. Consider it as equation number 14. So we have got a simplified expression for this particular solution of current. Okay, so we have got the simplified solution for the particular solution of current. Now we have to determine m value and theta value. So we have to determine m value and theta value. So for that purpose, let us consider these two triangles. Okay. So in this first triangle, you can see what you get, m sine theta by cos m cos theta. So m sine theta by m cos theta, it is nothing but tan theta. So from the impedance triangle, what is tan theta? 1 by omega RC or CR. Okay, so this m sine theta, m cos theta, this term I have got from the equation 12 and 13. I have taken the ratio of equation 12 and equation 13. If you take the ratio of equation 12 and equation 13, you will get this. So Vm you can cancel, and you will get 1 by omega CR you will get. Instead of that, you can go for these triangles. Okay, you can go for these two triangles, impedance triangle and this triangle. You will get tan theta. So tan theta is tan inverse of theta is theta equal to tan inverse 1 by omega RC you will get. So that is our equation 15. So we have determined the theta value. Okay, instead of using these two triangles, what you can do is you already have equation 12 and 13. You take the ratio of these two. Okay, this term will be cancelled, this term will be cancelled, Vm will be cancelled. What is left over is, what is left over? 1 by omega RC you will get from equation 12 and 13. So here you can write, to determine theta, take the ratio of equation 12 and 13. Okay, you can do that, or you can go for these triangles. So we have determined the value of theta now. Theta equal to tan inverse of, I didn't put the bracket here. Okay, tan inverse of 1 by omega RC or CR. So that is our equation 15. Now from this triangle, first triangle, what is m? M equal to root of m square sine square theta plus m square cos square theta. from substitute from equation 12 substitute m sin theta value, and from equation 13 substitute m cos theta value, and simplify. Okay, and simplify, you will get m value, m is equal to Vm by root r square plus 1 by omega c whole square, you will get. That is our equation 17. Now we have determined the theta value, we have determined the m value. Now substitute it in IP equation, that is equation 14. What do you get? IP is equal to Vm by root r square plus 1 by omega c square sin omega t plus phi plus tan inverse of 1 by omega rc. Consider it as equation number 18. Okay, we have an expression for IP now. Now we have to determine C value. Okay, so for before that, substitute. Now let us write down the total expression. I forgot about the total expression. Total current, total solution I. So what is I is equal to complementary part plus particular part. So I is equal to complementary part was C into e to the power of minus 1 by RCT, and particular part just now we have calculated, that is our equation number 18, that is Vm by root r square plus 1 by omega c whole square sin omega t plus phi plus tan inverse of 1 by omega rc, considered as equation number 19. This is the total solution for the current. Now in this total solution the unknown term is C. So let us determine this arbitrary constant. In order to determine arbitrary constant, let us consider the initial condition at t equal to 0 plus voltage across the capacitor is 0. The capacitor acts as short circuit. Okay, so since the capacitor is acting as short circuit, I can say that circuit acts as purely resistive circuit. Okay, circuit is purely resistive circuit. Circuit is purely resistive. Okay, it is purely resistive circuit. Therefore, what is the current in the circuit? As soon as switch is closed, let us assume current at T0. Means so current is I0 equal to Vm by R sin phi. So current in the circuit will be Vm by R sin phi, because capacitor is acting as short circuit here and circuit acts as purely resistive circuit. So consider this as um, consider this as equation number 20. So here what you can yeah, so here you can substitute 0, and here you can substitute 0, here you can substitute 0, here also you can substitute 0. So if you substitute 0, so Vm by root r square means r, Vm by r, this whole term will become 0, Vm by r sin this this is 0, this is 0, what is left over? Sin phi. So from equation 19, okay, so equation 19, this whole term becomes 0. This will become 0 because capacitor is acting as short circuit, means there is capacitor does not exist, we can assume. So this also term becomes 0. This term becomes 0 and this whole term will become 0. So what is left over? Vm divided by r square into sin phi, into sin phi. Okay, so that's what this is. As soon as switch is closed, current in the circuit is I naught is equal to Vm by R sin phi. Consider it as equation number 20. Okay. Now substitute the initial conditions in equation 18. Okay. So if you substitute the initial conditions in your equation 18, so Vm by R sin phi is equal to C plus Vm by R square plus 1 by omega C square sin phi plus tan inverse. Means here what I have done is I have substituted I naught value here. Here it is I naught. Here I have substituted 0. E to the power of 0 is 1. Okay. E to the power of 0 is 1. Here t also I have substituted 0. So this is 0 sin phi plus tan inverse of 1 by omega c r you will get. Okay. So simply substitute as considering I naught and t equal to 0, you will get this expression. Okay. So here what I have done is I have substituted I naught. Okay, in equation 18, I have substituted I naught value and t equals wherever t was there, I have substituted 0. So this is what I will get, and just rearrange the terms, you will get C. C is equal to Vm sin omega t minus Vm by root R square plus 1 by omega c square sin phi plus tan inverse of 1 by omega RC. So consider it as equation number 21. So we have got some expression for C. You can substitute this C in your main solution of your current. Okay, so this is it, substituting this 21 21 in your equation number 18. This is what you will get. I equal to Vm by R sin phi minus Vm by root R square plus 1 by omega c whole square. This is our C value, into e to the power of minus 1 by RC into t plus Vm by root R square plus 1 by omega c square sin omega t plus phi plus tan inverse of 1 by omega c r. Okay. So here this is our transient part. This is our steady state part. Okay. So the solution of the current has two parts, one transient part and one solution part. If we are writing it down, you just write it down quickly. Okay, now let us discuss a numerical problem on RC circuit. So series RC circuit has R equal to 20 ohms. Series RC circuit has R equal to 20 ohms and C equal to 100 microfarad. A voltage V is equal to 200 sin 314 T is applied. Okay, sinusoidal voltage is applied at T equal to 2.14 milliseconds. Okay, at time of 2.14 milliseconds, the supply voltage, a sinusoidal voltage of 200 sin 314T is applied. Obtain an expression for current. We have to determine current value. We have to determine current value and also find the value of current after. So we have to determine current after 1 millisecond also. Okay. So after 1 millisecond, we have to determine the current, and we also have to determine the current at t is equal to 2.14 milliseconds. Now Let us see the solution for that numerical problem. Okay. So here what we can observe is that the supply voltage, AC supply voltage, sinusoidal voltage. 1 second. So what we can see here is that the AC sinusoidal voltage is not applied at t equal to 0, but with some phase delay. It is applied at time, okay, 2.14 milliseconds. Okay, so what is that phase delay? Phi is equal to, we know phi equal to omega t. Omega means 314, isn't it? T is 0.00214 milliseconds. So 2.14 into 10 to the power of minus 3. If you simplify, you'll get 0.00214. Just multiply these two, you will get phase delay. Phi value as 0.672 radians. So there is a phase delay here with some phase delay. Okay, with some time delay. And to be more specific, with some time delay, uh, the switch is closed. Okay, so we are determining phi value. Phi equal to omega t. Omega means 314. T is 0.00214. So this is it. Phi equal to 0.672 radians. Okay, now let us apply KVL. Let us apply KVL. So to the given circuit. So what is it? RC, it's an RC circuit. So R into I of t plus 1 by C integral of I of dt is equal to, what is our voltage equation that they have given? V equal to 200 sine 314t. But they have mentioned that it will start with some time delay of 2.14. That's why I've determined the phi value. So we must add the phi value in this voltage equation. So I have added the phi values. That is 0.672. So now our KVL equation is what? 200 sine 314t plus 0.672 is equal to R into I of t plus 1 by C integral of I of t dt. Okay. And we already know the solution for this above equation based on the theory that we have discussed, that it will have two parts. One is complementary part, other one is particular part. What is complementary part? ICF is equal to C e to the power of minus 1 by RCT. So 1 divided by R into C. So what is R value? R value is 20 ohms into C is 100 microfarad. So just multiply R and value and C value, you will get e to the power of minus 500t. So the complementary part of my for the current solution of the current is what? It is ICF. ICF is equal to C e to the power of C into e to the power of minus 500t. Okay, now let's go for the particular solution. So there is no need for us to derive the particular solution. We already know the equation from the theory. So IP is what? What is the formula for IP? Particular solution Vm by root R square plus 1 by omega C square sine omega t plus phi plus tan inverse of 1 by omega RC. So substitute R value, C value, omega value and phi value, and you can determine the IP. So even Vm value, okay. So substitute all the terms. If you substitute, IP is equal to what? 200 divided by root of 20 square plus 1 by 314 into 100 into 10 power minus 6 whole square sine 314t plus phi value. This is phi. This is omega t. Tan inverse of 1 divided by omega c r. This is c. This is r. This is r. This is Vm. Vm. Okay. So substitute all the values and simplify. So after substituting all these values and simplifying, you will get this. I hope you have written. So, so total current. Did I write IT in the first expression? Yeah. So I of t. Okay. So I of t is equal to what? Complementary term plus particular part. So complete solution. So is I of t is equal to c e to the power of minus 500t plus just solve this 200 by 37.6. You will get 5.32. Sine 314t plus 0.672 plus 1.01. So this is not equation 1, isn't it? This is equation 1. Till now I didn't write equation 1 numbering. I didn't give numbering. Okay. Now let us consider this as equation 1. Okay. So this is our equation 1. So we don't know the C value, isn't it? We don't know the C value. So for that, so let us assume switch is closed at t equal to, they have mentioned in the question that switch is closed at t equal to 2.14 milliseconds when Vc equal to 0. We know when Vc is equal to 0, what is I naught equation in the theory that we have seen? I naught equal to Vm sin phi by r. So substitute Vm value, r value and phi value, you will get I naught equal to 6.22 amperes. Okay. Now we have I naught. Okay. Substitute t equal to 0 and okay, initial condition that is t equal to 0. We have I naught. You can substitute t equal to 0 and you can determine the C value. So I naught is what? 6.22 and you just substitute 0 here and here just substitute 0 here. So and simplify. So here I will write the same thing which I wrote earlier for the theory. I will write the same thing. What does it need to write? I will just copy it from the theory. So here I have substituted I naught value. I have substituted I naught value and t equal to 0. And I have simplified. I have got 6.22 equal to c into 1 plus 5.32 sine 1.628. So just simplify it. You will get 6.22 equal to c plus 5.29. Okay. So that is equal to c equal to what? 0.93 you will get. So c is equal to 0.93. Substitute in the equation 1. So you will get I equal to 0.93 e to the power of minus 500t plus 5.32 sine 314t plus 0.672 plus 1.01. You can add these two. I didn't add it here. I have left as it is. You can add these two terms. Okay. Now this is the complete solution. Okay. Now they have even asked us to determine the current for 1 millisecond time delay. So wherever t is there, you just write in the above equation, wherever t is there, you just substitute 1 millisecond. Here t is there, here t is there, substitute 1 millisecond. So that's what I have done, 10 power minus 3, 10 power minus 3. I have substituted, I have simplified. So I have got I equal to 5.414 amperes for the time delay for the switch to close, okay, at 1 millisecond. So if switch closes at 1 millisecond, this is the current. I is equal to 5.414 amperes. So that's it. I have discussed in the previous session. I have discussed RL circuit, response using differential equation using AC supply. Here in this session I have discussed RC circuit. Okay, that's it. I will create the Google form and I will just upload it in the chat box. Just wait. Fill the Google form as soon as you complete, just inform. Just mention in the chat box and leave the session. That's it. Today's session is over. Those who have completed can leave the session. If you have subscribed to my channel, you will definitely receive the notification regarding the online sessions, isn't it? Isn't it? So if you don't know when the session will start, someone has mentioned, I didn't know at what time session started, but yeah, I have read the PPT. Why? Because it's the derivation, isn't it? Step by step, I have already written. Okay. So if you want me to type each and every equation, it's wastage of time. Okay, it's wastage of time. It consumes lots of time. Yes, I remove. Yeah. So I have simply read. Yeah, that's what I have done. Because it's just the derivation. If you expect me to type, what do you expect? Derivations means what? Derivations means step by step we have to solve the expressions. I have already done the simplification. I have spent enough time to type all the equations. Okay. So each and every step clearly I have solved it and I have already written in my PPT. So what extra should I do there? Okay. Whatever extra that I have to do, everything with clear statements and equations I have written in my PPT. So it's just the simplification derivation part. So each and every part I have written in the PPT. So equations I have to read. Otherwise, what should I do? I have to just show you the equation, and you expect me to you go through the equation, and shall I skip 2 3 steps, and shall I say that write the KVL, solve it, determine current? I don't know what you are expecting. See, you are Chat GPT generation, not myself, isn't it? You are Chat GPT generation. Huh? So when I was studying, we didn't even had any proper internet connection. Okay, we didn't have mobiles, we didn't have internet connection and all. The thing is, when you attend a session, you must listen and you must understand the concept. Okay, you must concentrate on understanding the concept, not on what the person, whoever is delivering the lecture, how they are explaining it. Okay, so why I have written, if I orally explain it to you, okay, if I start writing, so you expect me to write. So for that, I can write it. I can buy a notepad and I can write each and every step, and you can copy it down. So writing with the hand is different when compared to typing the equation. Okay, so if you type the expression, it looks more eye-catchy, isn't it? The expressions which are typed are more eye-catchy than the expressions which are written. Okay, so you expect me to write first expression and you expect me to write next expression in the online session. If I do that, whatever I write, you just watch other videos. They are available in the YouTube. People just start writing on the notepad. Their handwriting will not be eye-catchy and it won't be interesting. Okay, so whatever hard work that I have to do, I have done before the class. So I'm just step by step explaining it to you so that you can understand and you can reproduce in your exams. That's it. Okay, so it's just the each and every step. That's what I do. It's not the theory, isn't it? If what Chat GPT, what IIT professors do, ma? What do they do? You just mention in the chat box. What do IIT professors do? They go to the Chat GPT and they will type whatever they want and they get the answer. So that is called copying and pasting, isn't it? One thing, okay, I have done whatever I can do. I have written each and every equation. I have spent enough time. I can do that. That's what I said. I can buy a notepad. I can write it. Okay, each and every equation on the pad. I can write it. It's not eye catchy. That's why I have typed it. Okay, so next session, if I take online session, uh, anyhow, see, many people are not joining the live session. Okay, so for only one person, you expect me to write by a notepad and write it on the notepad. So it means that you were unable to follow the session if the equations are already typed, isn't it? Say, someone does something, it's their own interest, okay? So if IIT professors, they want to write and explain as if they are writing at the first time, it's okay, it's their wish. Okay, no need to copy others. Whatever I feel that it is easy for the students to follow and to understand the concept, that's what I have done. So I have read whatever I have written in the PPT. So was it reaching you people? Were you able to follow it or not? That is important. How I'm teaching, simply I'm uh, okay. You were not, you were unable to follow the concept. So you do one thing, you refer to the textbooks or you follow some other YouTube video, okay, and try to learn the same concept. You will understand what I have explained. You listen to the some other lectures, many messages are there. You listen to some other lectures, okay. So I have done my best. I have written each and every step. I have typed each and every step, each and every equation, so that you will be able to follow step by step. And after that, I was just explaining you what you have to do next, what you have to do next. It is already there in the PPT. Okay. So we are not attending any session to judge, isn't it? We are attending a session to learn. How the other person teaches is his own wish. Okay? The way he wants to teach, he will teach. That's it. We are no one to judge others. The thing is whether we are able to follow or not. What are all the drawbacks because of which we are unable to follow? Okay? So that's what the explanation that I can give. If you have filled the Google form, you just leave. No need to just, it's wastage of time, isn't it? Unnecessarily. Some IIT professor follows some notepad, he uses notepad, so why should I use the notepad? I can do that also, but it's wastage of time to write it. Okay, if it is already written, it is easy for you to copy it down also. Okay, that's what I can say. Okay, then I'm concluding this session.